Welcome to the Spare Parts Podcast with FTC Team 535 Tobor. This is Episode 8, Programs Speak Louder Than Parts.
Hello and welcome to the Spare Parts Podcast with FTC Team 535 Tobor. Today we're going to be talking about some general aspects of programming. We'll get into more specific items later, but today we're just going to go through kind of general outlines of programming, good programming conventions, and other things to do when you're programming for FTC. So I'm Ben.
I am Connor.
I'm Tony.
All right then, and we are the crew for today.
So
for programming for FTC, we're going to start just by going kind of through the program structure. So the very top, you're going to at the beginning of everything that we do is inside its own class. So at the beginning of your class, you're going to define all your variables. That'll include the names of your motors and any other variables you want to do, integers, doubles, floats, whatever you want to do. You aren't actually setting any of those things equal to anything yet, certainly not the motors, but you're just declaring which ones you're going to have. Then you follow that with the FTC SDK, we have certain methods that we have to override. So I guess now would be a good time to talk about the differences between the op mode and the linear op mode. So the name is pretty self-explanatory. Linear op mode is linear, so it goes down through the list of code, doing one thing at a time progressively. We tend to use the regular op mode, which actually loops through it over and over again. Now you can construe that to work in a sort of linear way using switch statements, which is what we tend to do just because our mentors have kind of pushed that as what is more prevalent in industry. But you can use either one, and there are a lot of commonalities between the two, right?
Right.
So then inside your init method, you want to actually set all of your variables, particularly the things on your hardware map, so sensors and motors and servos, equal to something. And the way you're going to do that is you put the name of it, and then you do equals the hardware map, and then you retrieve it from the hardware map. We're not going to go into specific details of syntax in an audio version because we don't think that'll be very useful for anybody, but we will put up some examples as we move on through the year. Then, if you want to, in the regular op mode, there's something called the init loop, which is a loop that runs after the init button is pressed, but before you actually start the program. This actually turned out to be useful last year because we continually recalibrated our gyro sensor in between during the init loop. Because if we didn't do that, then it would have gotten off calibration in the maybe couple minutes between starting the program or between hitting init and actually starting the program. And then finally you get to your loop, for the regular op mode, the loop, and in the linear op mode, I'm not actually sure what it's called. It has a name. I don't know. There's something equivalent in linear op mode. In linear op mode, it would just run through the list of code. In the loop, it's just going to loop through that. And again, you can kind of get around that by using the switch loops. And then so in there, you're going to write your actual program to do whatever you want it to do. In teleop, the regular op mode is actually pretty useful because it allows you just to set motor power is equal to inputs from the joysticks directly, right? And then, so in autonomous, you can also use the linear op mode system to do one thing after another. You could also use the regular op mode in autonomous using a switch statement, as I was saying. And finally, then there's the stop, which essentially is whatever code is run when you hit the stop button. I would recommend just putting in there set all the motor power to 0.
And servos. They're motors too.
Mm-hmm. And that's actually a good point. In the initialization, you probably want to set your servos to their initial values. I don't know. Anything else you want to do in your initialization?
I guess if you're, I guess the color sensor you might want to initialize LED on or off.
Sure,
stuff
yeah.
Like that.
Mm-hmm. So basically what we get from this, folks, is the fact that look out online or listen to Ben's advice. There are a few tips and tricks to helping you with the program. Again, make sure that you utilize all the different ways of doing something, the most efficient way. As I believe Ben mentioned, you want to be able to comment everything so everyone can read it all. It's very important that you just know what you're doing, know your resources, to be able to come up with a fully functional and optimal code.
Yeah, and kind of on that note, it is very important that you comment your code, not only for the sake of your own sanity, but also for the sake of the judges. Most judges, just kind of as a byproduct of the way judges are chosen, aren't programmers, but they will be looking at your program, especially now that we have the control award. So it's good to put comments in your code as you're going along instead of having to go back at the end and add them all in for the sake of the judges' viewing of your code, right?
Not only that falls into our next thing where if you have multiple programmers on a team and you're working on separate codes or you're working on the same code, that's where that commenting comes into place. If you're working on two separate codes and then one of you is absent and needs the code finished, your partner should be able to go to yours, look at it, and have the basic understanding of what's going on, what it's doing, and figure out how to pick up where you left off. Same thing if you're working on the same thing. Make sure you understand names of motors, name of servos, sensors, and such, that you know that general information between the two of you. You've commented everything. It just makes life a whole lot easier between the whole team.
Yeah, so you'll definitely, as programmers, want to divide up labor as efficiently as possible, and that often means, say, assigning maybe a team of 2 people to work on teleop, a team of 2 people to work on one autonomous, a team of 2 people to work on another autonomous option. And having like common names for things, for example, motors. Like if you have a teleop program and 2 different autonomous programs, if you name like one motor right motor in one and you call it just right in the other, and then in another one, I don't know, you would call it R or something, that can get kind of confusing for people. And if you want to kind of copy chunks of code around between different bits of your program, that can get very, very terrible very, very quickly. So it's important to share naming conventions of items in your hardware map, because the hardware map is also shared globally among all of your programs, right?
Right.
You set up the hardware map once on your phone, and then the same string names get applied to all of your programs. Or I guess you could think of it as being vice versa, right?
Yeah. So everybody should just keep your code looking the same.
Yeah. And it's also good. So one thing that we've done in the past is just made kind of a wiring diagram or kind of a list with serial numbers of all the motor controllers and core device and the core device interface module and the sensor module, and made a list of what's plugged into which ports, so you can test it very easily with the core device discovery program. Which, by the way, we highly recommend that. It's made by Modern Robotics. It's just a program on a PC. They probably have them on Macs too, although I'm not sure. But what you can do is just plug the core device interface module into your computer and on a battery, and then you can pull up the list of what's plugged into it, look at it, run certain motors at certain speeds, set servos to certain values. It's a really, really useful debugging tool.
Yes, it's very. I think it also tells you the serial numbers on the.
Yeah. And it's also it can also show you the sensor values, so it can also be used for that kind of testing.
With I2C stuff.
Yeah, it really is an invaluable piece of equipment for debugging code and testing stuff out ahead of time.
It's definitely helped us polish our software quite a bit.
Yeah.
Which, very valuable resource, and I believe before you mentioned the kind of a hardware map or a map of wiring and stuff like that. Mm-hmm. That ties not only to, because programming is not just involved in the school where you're working out or the workshop, wherever you are, it goes right down to the competition itself. And so having that map of being able to tell what sensor is hooked up to what, where everything's plugged in, one, is extremely handy for the first part, which is when they come in and inspect your robot. When the inspector comes in and asks you what is connected to what, how does that work?
Well, that's usually not an issue at inspection.
Not too much of an issue, but it is nice, like, what is this plugged into if it's lost inside the general of your robot? And you know exactly what that goes to.
Sure.
But, of course, it plays other functions during a competition as well, such as, like you said, well, not particularly the wiring map itself, but commenting your code for judges. Having a code on maybe a thumb drive or something so that you can give that to them or other teams. Because we know a lot of rookie teams out there, they might have just something small thing that's wrong, and that you can be there to help them out with that or anything.
Yeah, and so I mean, different states have different requirements for the control award submission. Some require you to put them on flash drive. Some require you to print it out. Some require both. So you have to figure out ahead of time what your competition is going to require for the control award. For the judges to review your code. And for the sake of the control award, of course, you want to have everything nicely commented, as we were talking before, but it's also useful for your team so that other team members can see your code. Now, I'd also like to address, kind of on the note of the presentation and on the notebook, you want to make sure that at least every programmer, and really everybody on your team, should have at least a general understanding of what the program is doing, right?
Right. They don't need to know like how to program itself, but they need to know. They need to be able to look at it and say, oh, during this part of it, this is what happens. And
sure, yeah, and I mean, not everybody on your team may be very interested in programming. I know that's certainly the case on our team, but those who do, being able to explain programming is a really good mark that you actually understand what you're doing and that you are a good programmer.
Oh, yeah.
If you can explain, I mean, doing and explaining are two different things. If you can do something, you can do it. If you can explain it, then you really understand how it works and why what you're doing it works.
And like you mentioned, if the whole team in general has an idea of what's going on in the program, that's optimal, because a good judge will, of course, see who's specifically commenting about the code in your group, and then they might turn to someone else and ask, what do you think about it? And it's good to be prepared for those instances. Same thing when you're at your table and a judge comes by to ask about the code. If a programmer is out doing something else and only another person that's left behind, it's good that they also have at least a brief way of explaining what's going on there and show a general knowledge of it.
Yeah, so kind of the bottom line is that being able to explain the code to everybody benefits all of the team members because they understand what's happening, benefits your team because the judges will then be kind of impressed by that everybody, even the non-programmers, know something about the code, and it benefits the programmers because they really have to kind of ask themselves and very deeply understand how everything works and why it works.
speaking of that, a thing that every programmer should know heading into a competition are the queuing rules with programming. So
sure, yeah. I mean, it's a very simple rule. You can't change your code in the queuing area, so don't even take your laptop with you. It's against the rules. That's about it, right? So make sure that you get your code ready ahead of time.
Of course, you have to have it finished. You don't want to be on the bus ride to the competition and, just scrambling to make a motor turn or anything,
I mean, if you have to, of course, I know there have been a lot of teams, including us, who do programming at the competition.
Desperate times call for desperate measures.
Yeah, but you want to avoid that as much as possible. So, and that kind of moves on into our next, advice about time management is that you need to leave time for programming. You can't just kind of push programming off to the edge for the entire season. You have to allot time, certainly for building, but once the building's done, and even if the building isn't perfect, at some point you have to cut off the building because an imperfect build can be seriously improved by really good programming.
Especially this year with the amount of points able to be scored in the autonomous mode.
Yeah.
Programming is as important as ever now.
Mm-hmm. Definitely. So programming is very critical to your success. And as I was saying, good programming can overcome kind of bad building or even bad design to some extent. Not completely, but to some extent, right? And this year, programming in autonomous is going to be very, very important because you can score a lot of points during autonomous. So let's just kind of quickly go through a perspective of all the different things that you can do and that we're kind of excited about in programming. So going through this year's game, in autonomous, of course, just as we could last year, you can follow the lines to the beacons, right?
Yeah.
Yeah. So line following is a pretty important aspect, or line following is a pretty important thing in robotics. And it's an interesting programming challenge. You've got your color sensor, you can see whether you're on the line or not, and then you can adjust your motors to kind of back and forth and stay on the line as straight as possible.
Quite literally the bread and butter of robots being able to tell where they are and move precisely.
Actually, something I'm very excited about this year that they brought to FTC now is the image processing.
Yeah. We'll get to that in a second,
okay.
I think. So line following is pretty easy to learn how to do, and it's certainly a huge way to score points very quickly. And I will point out, so that we're kind of thinking line following, you have a color sensor on the ground, facing the ground, and you see the line. The rule basically is the more color sensors you have, the more accurate you can be, right? Because if you've got 2 color sensors, they both need to be on the black with the line in between. If you get 3, you get 1 on the line, 2 on each side. If you get 4, you put 2 in the front, 2 in the back, and follow that way, right? So as a general rule, the more color sensors you have, the better your program is, the better line following can be, but there's kind of a diminishing return on investment there. The more color sensors you add, the less the improvement for every additional sensor becomes, right?
Yeah, and even like I think the I2C device actually has a weird bug in it where like.
Well, that's actually a very good point. Yeah. So the way that modern robotics has their sensors, all color sensors have a certain address to start out with. I think it's
32C.
3C. I think it's 3C.
3C? 3. Oh yeah, it is.
0x3C. Right, so that's hexadecimal 3C is the I2C address of normal
40.
color sensors.
Right.
Now, if you want to use multiple color sensors, or in fact multiple of any type of I2C sensor, you have to change the address of the second one. And you can do that in the core device discovery program that we just mentioned. And then you have to use it as an I2C device in your code. And that applies to all I2C devices because they're all on the same bus, and so you don't address them by where they're plugged in, you address them by their address, their name, essentially.
Yes. Which gets a little annoying to deal with, but I mean...
It does, yeah. Now, if you want to have, say, 3 different, so like a gyro, a color sensor, and what? Is sonar I2C? I don't think so.
No, it is, I think. A
It is?
rangefinder is. I think, right?
Maybe. Okay, yeah, so say you have a rangefinder, a color sensor, and a gyro sensor, you'll be fine. But if you have 2 color sensors or 2 gyros, then you have to start worrying about the I2C addresses. So I guess we brought up the gyro sensor, which does exactly what it sounds like it does, right?
It's the world's best sensor.
Yeah, so it measures your direction on 3 axes.
Right. And it's been improved from what was 2 years ago. That gyro sensor was a pain in the butt to deal with.
The Lego gyro
Yes.
sensor, yeah. Those were terrible. So it's much, much easier to use these. They're much more intuitive. And you can do some very interesting things with the gyro sensors.
But we should say that, I think we mentioned this at the beginning of the podcast, when you calibrate a gyro sensor, it takes a little while to warm up.
It does, yeah. Calibration typically takes, 10 seconds, a bit less than that maybe. And you have to allow that to happen before you actually run it. Otherwise, you're going to get garbage readings.
Yeah.
So, and we also brought up the rangefinder, which uses sonar waves and kind of counts the amount of time it takes to get the sonar waves back to measure distance between the robot and something else, right? So I can imagine that could be pretty useful this year for like telling how far away you are from the beacon, right?
Well, yeah, I think so. That would be because it has much more range than like a color sensor does.
It does, yeah. And I've always been kind of interested in using it like to spot other robots and go around them, like in autonomous. If another robot is coming in front of you to block you, see that with the sonar or with a rangefinder and drive around the robot.
That would be amazing.
Yeah, that would be amazing.
That would be called a bat.
Well, basically. There is also a light distance sensor, which we've had very limited success with before. Usually, in our experience, it doesn't work that well.
Something to do with all the lights inside of the competition.
Well, it does, and certainly it's no good at finding transparent field walls, right?
Yeah.
But
reflective.
If you want to have the most worthless sensor ever, use the compass sensor.
Well, I'm not sure it's completely worthless. In general, I would say it's a lot less useful than the gyro. Particularly because fields are oriented differently, so you're going to have to do initial calibration to begin
at least
with.
you know where west is.
The compass will get screwed up with all the magnetic parts of motors, but
do we even? I don't think
it's
have
a
modern
physical
robotics compass sensors.
I'm not sure. Well,
I think that's old Lego stuff.
Is it? No, I think. Well, whether it's old Lego or modern robotics, I know it's integrated with an acceleration sensor, acceleration sensor, so you can use it. For that too, just ignore the compass.
Oh, so it's just an accelerometer?
Yeah, well, it's an accelerometer and a compass together, like combined.
Okay.
You're having nightmares, Tony.
So I think maybe it's just an accelerometer and a gyro sensor combined, right?
Probably. Okay.
not for sure.
Yeah, I don't think it's actually a magnetic compass, but I think
I doubt
Lego
it is.
did have an actual magnetic compass.
Which is amusing. But
Yeah. So any other sensors? I think we covered most of. Oh, I guess
world's
there's a
best
touch
sensor.
sensor.
Yeah, touch
Right.
sensor. Woo!
Which can be very useful, particularly on your robot if you want to sense kind of where your arm is or something. I mean,
when nothing goes
that could
right,
be
give it a
pretty
good
useful.
poke.
And in general, on the field, I would say it's probably less useful than the sonar sensor because you have to be right up to something in order to touch it. But you could potentially use it that way to sense like how close you are. Well, to sense whether you're a certain distance from the wall or not.
Instead of just ramming your robot meaninglessly into a wall, now you can ram it meaninglessly into a wall and know about it.
Did we mention the IR sensors or?
No, we didn't actually. Which
is
IR
pretty big. Can't forget
sensors
about.
used to be very, very important in FTC, and they aren't anymore. Basically,
Yeah.
I think that for like the certainly during Block Party, Cascade Effect, and Ring It Up, they definitely were all very important in the game. And for the last 2 years, they haven't been. They've just kind of been scrapped in favor of the beacons.
That's true.
So IR might come back, but specifically in the game, it's not that useful. But we have also, the thing we use an IR sensor for, we've got a nice ball that has omnidirectional IR emitters in it. So we roll that ball around and have a robot chase it. That's really fun to take to outreach events and have little kids roll the ball and the robot chases it.
It gets really scared though when the ball gets next to a kid and the robot tries to get the ball. The kid doesn't know the ball's after.
You know what is fun doing? Taking that same code and putting it onto another robot and having putting the IR ball into a robot that you'd manually drive around and you have like a duckling of
Or you could just use like a regular IR beacon. Or like one thing we did at one point was like take a robot for a walk, you carry the IR beacon behind you, the robot follows you, right?
Yeah.
So that's fun.
Big hit.
even though the IR sensors have very limited scope this year within
Exactly.
the game, or for the past 2 years within the game. Now, you aren't limited to modern robotic sensors. You can technically use any kind of sensors you want to, as long as you can get them to work.
But we are sponsored by Modern Robotics, so just say
Untrue.
that is untrue.
Please buy today.
We highly recommend modern robotics, but we are not sponsored by them.
But I mean, we actually have a legitimate reason. If you buy like a third-party sensor, I think there's a bit of manual setting up. You have to do that. The APK files in Android Studio already have.
So a lot of the dirty work of programming sensors has already been done for you with the modern robotics stuff within the FTC SDK. I would not recommend that you go out and buy a third-party I2C sensor. You might be able to get it to work, but it's going to take a long time. Now, we have had success going out and buying third-party PWM sensors.
Yeah.
And so actually the way we implemented that last year, we got very, very small IR line sensors. And so essentially it's kind of like a color sensor except it uses IR light. And black colors reflect less of the light than does the white line. And so we used that last year. We put a color sensor in the middle to sense the white line, and then on either side we put an third-party IR line sensor, a very, very small, simple PWM sensor we put on either side to sense whether we were on the black. Now we had to make our own circuit board and add some resistors in there, which was a bit complicated, but it's certainly possible to integrate third-party sensors. And if you just do the 2-pin sensors, those would probably be very easy just to integrate. All right, so we've gone pretty far down the rabbit hole of sensors.
Yay.
Now I will point out that you've got this wonderful device with a whole load of sensors in it on your robot already, your phone, right? And I mean, the phone has gyro sensors and other things.
Compass.
Accessing that information is much harder than it is with the modern robotic sensors.
Right. But it is legal.
It is legal, and it is
there.
possible, and it might be easier. I don't know.
Right. And so, I mean, they have this thing, the Vuforia.
Yeah, so the other big sensor on your phone actually there are two of them, the cameras, right? And so this year, Tony,
We're working with Vuforia to do image processing to find the images and create a matrix of the field to know our exact location so we can party hard.
we are. That's one of the most exciting things this year in programming, I think, is we're going to be able to use the phone's cameras to be able to look at the field, recognize images, and then from that figure out where we are on the field. Now that involves some interesting matrix math, so you'll have to learn some things to get this working.
So you college freshmen will have a great time.
Yeah, linear algebra, right? In order to, so the way it works essentially is actually a lot of the work has already been done for you. The part about recognizing the image already exists in the SDK.
Right.
So what you have to do is give it a bunch of different examples of different angles of the image, and it'll recognize the image very, very well in our testing so far.
Yeah, and it measures distance and everything, and it's so great.
Yeah, and once you have recognized the image, you get matrices back that relate the distance in all 3 dimensions and the angle that you're tilted compared to the image. And so based on that, you can navigate around the field very effectively, and that's the reason that we have those pictures underneath the beacons this year.
The next step is to download IBM Watson, and then it will drive for you.
Yeah, so we definitely can recognize those pictures and use those to figure out where we are on the field and to navigate, and those are very precise, like down accurate to maybe a centimeter or 2,
yeah,
maybe even
so.
less than that. So that's a very, very accurate navigational system, and you can use that to go right up to the beacon perfectly, if you can get it to work.
Which we're still in the process of doing.
Yeah. So we know from our testing that we can very reliably recognize those pictures. And what we're actually going to try to do this year is recognize a ball. So kind of our pipe dream this year is to be able to recognize a ball, drive up to it, collect it, turn around, recognize how far away we are from the goal, angle our shooter to the correct distance, and have automated shooting and collecting.
You heard it here first, folks. Tobor 535 will create the first autonomous teleop robot.
Now that may not be true. That may not
fantasies.
end up being possible because of all the balls
Complications.
can look very different, and like if you have 3 balls next to, or like 2 balls next to each other, and even the goal I think is going to be really difficult
Yeah,
to
that
do
would-
because of the way how high it is and how many different angles it could be at.
When the AI decides it doesn't want to be ruled by humans anymore and tries to kill us all.
But yeah, so I think that's a possibility, and definitely you can use the image tracking before you to know where you are in relation to the beacon images and to get up to the beacons almost perfectly during autonomous. So that's something that's really exciting this year, and it would really impress the judges if you can get that to work out and explain how it works, right?
Yeah.
Definitely.
So anything else exciting about programming this year?
Well, I know with the updates to Android Studio, it's been slightly easier to do stuff like you don't have to register op modes and
Sure,
whatnot.
yeah, there have been a few tactical things that have made things a bit simpler. One thing I really like is the new version of the SDK doesn't have so last year, if there was a disconnection, you're done for the rest of the match, right?
Yeah.
But this year, if there's a disconnection, that single motor or whatever will stop working, but everything else will continue working, and once it comes back online, then it'll start working again. Whereas last year, it would throw it, well, I don't think it technically threw an exception, but it stopped the entire code.
Right.
Whereas this year, it won't have.
So instead of just standing there and doing nothing, instead your robot will move in slightly donut-like circles because one of its motors turned off instead of all of them. Be
Well,
happy.
Like,
Yeah, it's possible.
I mean, if you have like a motor go that's not like not critical for your play of the game, I guess. I mean,
You
Yeah,
play
still.
the game.
Sure. Yeah. And you don't want to have your motors go out, but
Yeah.
if it's like out for a second, last year that would have meant you're done for the rest of the game.
Yeah.
But this year that means it's out for a second and then you can shoot or
comes back
collect or
online.
drive, whatever.
yeah.
One thing that we actually forgot to mention was encoders, which I think we just kind of skated over because they're so basic. But encoders are also sensors. They count revolutions, basically. So with the new Andy Mark Never Rest motors, they're built in. With the older motors, you have to put them on the head of the motor. But they count well. So on the new ones, it's it's not 1440. No, that was on the old ones. It's
This is news to me.
is it 1120, 1150?
Why,
I'm not
that's,
sure.
you might call that revolutionary.
It's definitely not 1440 because that's what it was on the old ones.
Right.
It's this year. Well, regardless. So encoders, count fractions of rotations and actually fractions of degrees, so you can get very accurate with them. But they're very useful for counting how far you've driven, or for like setting your motors to certain positions or something. One thing that's actually built into the SDK, if you at the beginning use run using encoders, there's something called PID control, and what that does, so different motors are what we call burned out to different degrees, right? There's tiny mechanical issues with them or something.
And then if you keep using them over time and over time and over time, then eventually they get really burned out. That's when you start smoking.
So that's those tiny mechanical flaws are gonna cause differences between two different sides of the robot, for example, with your drivetrain.
Yeah, even if they're minuscule differences, it can cause like a great impact on your robot's drive.
Over time, yeah.
Over time.
One side can catch on fire,
it's
the other side won't.
exponential, right?
Yeah. Exponential.
Well, it'll just continue.
It's not exponential,
Okay,
but the
I
error adds up over time.
Because
right?
the error
It's
is not
kind of
going to get better. It's
what,
just going to get
Euler's
worse.
method for doing differential equations, where
Oh,
the error
no.
just keeps stacking up, right?
It's called interest.
Yeah. Well, so regardless, PID control counts encoders and dynamically increases or decreases the motor power to compensate for that. Now, PID control, so if you're, say, using your gyro sensor to drive in a perfectly straight line, you want to turn off PID control, because the PID control will override the instructions coming from your gyro sensor, which would have been more accurate.
I remember.
But if you don't have any sensors, or if you're not following the line or anything, then you probably want to use PID control, because what it does, it's all programmed for you, and it just dynamically checks to see whether the power that's been applied over the time that it's been applied for matches the encoder count, and if it doesn't, then it compensates for that.
Right. And if you have any of these questions, there are several sites you can go to do research on code and sensors, like
so we've got some information about programming on our website, and we're going to continue doing a string of podcasts about programming. This is kind of just an introduction.
We're also making sheets on individual sensors and how they're used and integrated.
Yeah, those are coming up soon, within a couple of weeks, hopefully. Also, by the end of November, we're going to have our scouting app ready. So we will definitely make sure to distribute that by the end of November. Anything else?
I think that's it.
I believe
All
so.
right, then. Well, thank you for listening to the Spare Parts Podcast with Team 535 Tobor.
This has been Tobor time.